And what do you think that chemical might be that settles down on the fire? Since we've read something about how to put out fires, what is that gas which would be heavy enough to actually descend on the fire?
Carbon dioxide.
Carbon dioxide. Very good.
Good morning. My name is Kusum Wagle and I work with middle school science students.
And therefore, what happens if it's heavy enough to settle on a fire, Rosalia? What happens? What is it in effect doing as far as the fire triangle goes? Shutting off what there? The air, the oxygen supply. And the moment one bit of the triangle collapses, the entire fire triangle collapses. So she's right, it's cutting off the oxygen.
My name is Amy Tong, and I teach Science 6 and Science 7 and also Biology 8. So a little bit about middle school science. Again, a lot of hands-on learning, and especially in 6th grade, we try to teach them good and safe laboratory skills.
I like goggles. I do.
Jude. Oh my God, you're messing up. A bit more.
Our overarching theme for the 7th grade is how do my actions impact the environment? And the overarching theme for our 6th graders is how can I be a good and effective scientist? We have a very hands-on program, and of course the slogan at middle school is explore, connect, empathize, create.
Chemicals, and we're also going to have some dishwashing liquid which will provide the foam for it to spread, and that is what makes it really messy.
Oh my God,
The fun and the enthusiasm, we're very lucky. We teach a subject that goes with that. And of course, the fact that they're exploring and finding new things. And really, I do tell the kids that it's not always the right answer we're looking for. We're looking for the process. And it's okay to make mistakes.
So Milo, when he said sugar, he made a connection very nicely. The sugar syrup was the densest, and sugar adds a lot of density.
Natural flavor. That's why you have to say natural flavor. That's why when you have lemonades and stuff.
The thinking routines have definitely helped deepen the understanding. Of course, hands-on science also helps, but we don't want the kids to leave the classroom with just a superficial knowledge of things. We want them to make connections. We want them to see the bigger picture.
What do we use density for in the real world? Malcolm?
We use density to measure if anything will sink or float, maybe?
Find out the density of?
Of anything that we want to see if it sinks or floats.
Right, but what did you just say? Did you say something else? Did you give an example?
Well, you could find out if a log could float in water.
Absolutely, absolutely. What else would we want to find the density of in water? Stephen?
Let's say somebody's making a boat, and of course they have to use metal to make the boat, or they can use wood, but they have to have something that can counter the heaviness of the metal, so they might add something completely buoyant or air that can float on the water.
So thinking routines, which Project Zero introduced us to, help enormously. For instance, when our kids went on the Potomac River trip to work on the Chesapeake Bay project, we did the thinking routine of step inside.
I am the Potomac River, big and I flow by. When people throw their trash at me, it makes me want to cry. The cars that drive overhead make me dirty and it's mean. I hope that someday they will stop and I will be somewhat clean. I believe my wildlife should have a healthy habitat and much food and clean water that they unfortunately lack. I care for the environment and hope that you do too, so please take care of me as I take care of you.
Where they had to come back and be the Potomac River and think of all the trials and tribulations the river is going through, whether it's improving, what the people are doing to it. And some of them came up with very, very interesting, insightful comments.
Are you guys ready?
Yes.
How many people did number 1?
Woo!
Okay.
Number 1.
Are you ready for the reveal?
Yeah.
Oh!
Yes!
No way!
Yes!
Yeah, black box lab. So you're probably going to see footage of the kids doing a black box lab, and basically it's the first time that they're really being introduced to the structure of an atom. But, you know, when the scientists figured out what the structure of an atom was, they weren't able to actually see it.
Easy ones. 11, 4, 1, and I'm on 5.
By using their powers of observation, how to infer and hypothesize about what an atom looked like.
Now, we're talking about the atom. Why do you think we did this activity? Okay, Orianne.
Because it shows how difficult it is to really like give a good guess if you can't really know.
She could have just said it was difficult, though.
If you can't see what it is.
It's hard, right? How many people were frustrated?
Me!
How many people really wanted to know what was inside of this box?
I was about to crack the box open.
Okay, well,
you didn't.
these scientists could not crack the box open.
After that, we go into the different experiments that led these scientists to figure out what an atom looked like.